It's the giant ball of fire that gives us life, lights up our skies, and keeps us warm. But how much do you really know about the sun? Did you know it's big enough to fit over 1 million Earths inside? Or that without it, we'd freeze in just a few days? Stick around because in the next 20 minutes, we'll uncover some of the most fascinating, mind-blowing facts about our very own star, the sun. Let's start with the basics. The sun isn't a solid object like Earth. It's a gigantic ball of plasma, a superheated state of matter made of charged particles. Plasma is the fourth state of matter, along with solid, liquid, and gas, and makes up 99% of the observable universe. It's incredibly hot, and the sun's core is where all the magic happens, reaching temperatures of over 27 million degrees Fahrenheit. That's hot enough to melt any material on Earth in seconds. But it doesn't stop there. The sun is not just a passive ball of fire. It's a highly dynamic, active star. The process occurring in the sun's core is called nuclear fusion, where hydrogen atoms combine to form helium, releasing vast amounts of energy. This energy in the form of light and heat powers the sun, and by extension, life on Earth. It's the process that has been fueling the sun for billions of years and will continue for billions more. And speaking of size, think the Earth is big? Think again. The sun is so massive that you could fit 1.3 million Earths inside it. But here's the kicker. It's not even the biggest star out there. In the grand scheme of the universe, the sun is actually just an average-sized star, known as a yellow dwarf. While yellow dwarfs like the sun are among the most common types of stars in our galaxy, they are dwarfed in size compared to supergiants and hypergiants, which can be hundreds of times larger. But for us, the sun is plenty big, and it accounts for a whopping 99.8% of the total mass in our solar system. That means every planet, asteroid, and comet combined is just a tiny fraction of what the sun weighs. This incredible mass is what gives the sun such powerful gravity, enough to keep all the planets, moons, and countless smaller objects in orbit around it. Here's a sobering thought. The sun isn't eternal. It's currently about 4.6 billion years old and halfway through its life. Scientists predict it will shine for another 5 billion years before running out of fuel. But don't worry, its end won't be sudden. In about 5 billion years, the sun will begin to run out of hydrogen in its core, causing it to expand into a red giant. During this phase, the sun will become large enough to engulf Mercury, Venus, and possibly Earth. But before you panic, this is a long way off. Human civilization will likely not be around to witness it. After it sheds its outer layers, the remaining core will shrink into a dense, Earth-sized object called a white dwarf. Over the course of billions of years, the white dwarf will slowly cool and fade, leaving behind an intriguing remnant for future astronomers to study. Let's talk heat. The sun's core is insanely hot, over 27 million degrees Fahrenheit. But did you know the outer atmosphere, called the corona, is even hotter? The corona can reach temperatures of over 1.8 million degrees Fahrenheit, hundreds of times hotter than the surface itself. Scientists are still trying to figure out why the corona is so much hotter than the surface, but it likely has to do with the sun's magnetic field and solar winds. The magnetic field of the sun is incredibly complex, with lines of force that stretch from the poles to the equator, and these magnetic fields play a significant role in heating the corona. The sun isn't just a calm ball of light, it's constantly erupting with energy. Solar flares and coronal mass ejections, CMEs, release massive amounts of energy into space. Solar flares are bursts of radiation that can disrupt radio communications and GPS systems, while CMEs are massive bursts of solar wind and magnetic fields that can affect the Earth's magnetic field. When these solar storms hit Earth, they can cause disruptions in satellites, power grids, and even create the stunning auroras we see near the poles. These displays, also known as the northern and southern lights, are caused by charged particles from the sun interacting with Earth's atmosphere. One of the most infamous solar storms in history was the Carrington event of 1859. This massive solar storm knocked out telegraph systems worldwide, causing fires and widespread electrical disruptions. If a similar storm hit today, it could wreak havoc on our modern technology, disrupting satellites, communications, and power infrastructure. Ever wondered how long it takes sunlight to reach Earth? The light we see today was created in the sun's core over 100,000 years ago. That's because it takes that long for energy to travel from the core to the surface. Once it reaches the surface, the sunlight takes about 8 minutes and 20 seconds to travel to Earth. So every time you see sunlight, you're witnessing a journey that started over 100,000 years ago. It's a long journey for a single photon, but it's essential for sustaining life on Earth. Here's a fun fact. The sun isn't actually yellow. If you were to look at it from space, you'd see that it's white. The sun emits all colors of visible light, which combine to appear white. So why does it look yellow from Earth? It's because Earth's atmosphere scatters blue and violet light, making the sun appear yellow to our eyes. During sunrise and sunset, the scattering is even more dramatic, giving us those beautiful orange and red hues that we all love to watch. But don't worry, you won't ever get close enough to feel the sun's pull. It's too hot for that. In fact, the closest we can safely get is via spacecraft that study the sun, like NASA's Parker Solar Probe, which in 2021 became the first spacecraft to fly into the sun's corona. This mission is gathering data that could unlock more secrets about how the sun works and its influence on our solar system. The sun is more than just a glowing orb in the sky. It's the reason we exist. It powers life, shapes our planet, and reminds us of the incredible forces at work in the universe. It affects our climate, dictates our seasons, and has a profound influence on Earth's weather patterns. And while it's just one of billions of stars out there, to us, it's irreplaceable. From its magnetic storms to its nuclear fusion, from its colossal size to its vital role in supporting life, the sun continues to be a fascinating, mysterious force that defines our existence. We may only be able to observe it from afar, but the sun's presence is felt every moment of our lives. If you love learning about the sun, don't forget to hit that like button, subscribe, and ring the bell for more amazing videos about the wonders of our universe. See you next time as we explore even more cosmic mysteries.